This lesson will teach me to factor a perfect square trinomial and factor a binomial difference of two perfect squares. We've worked with both perfect square trinomials and difference of two perfect squares in previous lessons within this unit. Both of these are referred to as special cases. Here is the very generic mathematical language for perfect square trinomial and difference of two perfect squares. These are the problems where, let me give you an example. You recognize that you had the same value repeated twice. These were the problems that when you double distributed, you ended up with that center term 2 times, so they always doubled. So notice a plus b squared, a plus b squared. Here's your a value. It was a squared. Your b value at the end is squared. And the center is 2 times the value of a and b. Well, a times b is 2x, times 2 is 4. Also works the exact same if we have different signs. So if this would have been a x minus 2, it would have worked out that you would have had minus 2x and minus 2x, and then negative 2 and then negative 2 still would have made a positive 4. So we would have had our a value squared, our b value is squared, and you still have this a value times that b value, but 2 of them, 2 of them would multiply or double. So that is the perfect square trinomial that we called PST. Difference of two perfect squares, and it's really called a binomial difference of two perfect squares because your answer ends up being a binomial, or over here, notice your answer ends up being a trinomial. So in these particular cases, these were the problems where you said, hey, these values are identical except for the signs in the middle, because if they actually were identical, they'd be a perfect square trinomial because that's what made it square. So one's a plus and one's a minus, and these are the problems where when you double distributed, those two center terms canceled to 0 every time, and this end term was always a minus. That's why it's referred to as a difference, and these values are perfect squares because they were made by multiplying the exact same thing by itself. Think about area of a square. So looking at this kind of formulaic thing, the a values get squared, the b values get squared, there's no middle term because they canceled every time. All right, identify each as either a perfect square trinomial, difference of squares, or neither. Then you're going to factor. This is a difference of squares. I see two perfect squares with a minus in between. Difference of squares. Perfect square trinomial. This one will also be a perfect square trinomial. All right, let's go ahead and factor these. Difference of squares factors into two things. Think about the signs. One has to be a positive, one has to be a negative, because those two center terms end up canceling, which is what makes it a binomial. Same thing's going to happen here. Two things that made the x squared were the x and the x. What made the 16? Well, a 4 and a 4. One's got to be positive, one's got to be negative, and the order doesn't matter as long as one's positive and one's negative. And that's because the center term cancel, leaving you with just that minus 16. Perfect square trinomial. Let's see. What made the x squared? Well, an x squared. What made the 9? Well, a 3 squared. What made the x? Well, a 2 times a 3 times the x, 2 times a times b. These two things, if you don't believe me, multiply them out. The x squared came from the x times the x. The 6x came from those two 3x's, and there's your 9. Perfect square trinomial again. What things made the x squared? Well, the x squared. What made 36? 6 squared. What made the negative 12? A 2 times a 6, oopsies, 2 times a 6 times an x, but I bet that was a -6 to make it a -12. These ones down below are a little bit harder, and you might need to apply your pattern to some of them. So I recognize it as a difference, gosh darn it, of squares. So that's kind of how we start them. But here, instead of there being a 1 in front, there's a 4. So we always did an x and an x. Well, what would have made the 4? Let me switch colors here. A 2x and a 2x. Well, what would have made the 9? A 3 and a 3, 1 plus, 1 minus. If you go ahead and double distribute, you end up with your 4x squared. This is a positive 6x and a minus 6x minus 9. So even though it looks a little weird because there's more going on, those center terms still end up canceling. So the answer is what we really thought it was. Notice the parentheses are identical except for their sign, which is what we're looking at for a difference of 2 squares. All right. I see an x and a 16, so those are perfect squares. I'm going to go ahead and try to see if it's a perfect square trinomial. So x, what makes 16? Well, a 4 because of this sign. Let's just try that. Think about it for a second. You'd have an x squared. Your 4 squared is going to give you, but that's a -4 squared is going to give you a positive 16. I don't think it's going to work. And if we took the -4 times the x times the 2, it'd give me -8, not -6. This isn't a PST. Doesn't necessarily mean that it's prime. It means that we need another method. Things that multiply to give us 16 that add to give us 8. It's going to be x minus 8 and x plus 2. Nothing wrong with the problem. It can still be done. It's just not special in any way. Go ahead and try letter G. I see a minus. I see 2 terms. Let's check to see if it's a difference of squares. What 2 things multiply to give you 100? 10 and 10, 1 plus, 1 minus. Will those 2 center terms cancel? They will. Here's your answer. 3 terms, so my mind is already thinking perfect square trinomial. Is that a perfect square? Yes, it's made of 7 times 7. Is this a perfect square? Yes, it's made of x times x. So I'll have an x, let's see what sign, that's a negative, so -7 squared. Let's go ahead and think about it. Here's my x squared, my -7 squared is 49. If you did take a second to double distribute, you'd find out that you have 2 7x terms, leaving you with the -14x. All right, 2 left. I guess I've got 3 left. These are slightly different because this one looks a little bit out of order. I say keep it in this order. You can still do it. Try to find a greatest common factor for some of these that seem to have kind of bigger numbers. If you take a 5 out of both, so I take the 5 out, it's still a difference. This is still a perfect square, and the reason why, so if you think about the area of a square, if you did x to the 3rd times x to the 3rd, when you multiply like bases, you add the exponent. So it is a perfect square. So the 5 is sitting here. What 2 things multiply to give you the 1? What 2 things multiply to give you 4? And what multiplies together to give you the y to the 3rd, or the y to the 6th? 1 plus, 1 minus. If you don't believe me, check it. Letter J. I see that there is a 2 here, and I really like them when they have 1s. Look at all 3 terms. It looks like 2 is the greatest common factor. Okay, now look at what's in the parentheses. Is it a perfect square trinomial? That's a perfect square. That's a perfect square. So, yeah, x squared, 3 squared is 9, and 2 times 3 times x is going to give you that center x. All right, letter K I don't believe is in your notes, but I want to show it to you anyway. This one is a perfect square trinomial, even though it doesn't appear to be. If you think about 4x squared, it's a perfect squared. It's a perfect square because what makes it is 2x times 2x. We know that 9 is a perfect square because it's made up of 3 and 3. So this one you really have to follow your patterns. Kind of take a chance. Then I would always go back if it's something you're not sure about and double distribute. That's your 4x squared. That's going to give you 6x. There's another 6x, so you have two 6x's, which is going to give you the 12, and 3 times 3 is 9. The purpose of these special cases is it allows us to apply a pattern to problems that we wouldn't be able to do using our traditional product sum circles. Most of the problems up above, letters A through D, can be done using sheer product sum circles, but not all of them can be, which is the purpose of showing you the patterns. Go ahead, take a second and factor by grouping. This is here just so that you don't forget. All right, go ahead and check your answer against mine. I put parentheses around the first two terms. They had an x to the fourth in common. X squared minus 1 was left. I put parentheses around the second two terms, took out what they had in common, was a -9, because I needed this to be an x squared minus 1, so they matched. You can write these in either order, but you have an x to the fourth minus 9 in one parenthesis and an x squared minus 1 in the other parenthesis. In previous lessons, we kind of stopped here, but if you look at each of these, this is a difference of squares. It can be broken down. And, oops, forgot my square. And this is a difference of squares. So there's really 4 things that multiply together to give you the original. So we applied factor by grouping. Then I went, well, shoot, there's my answer, but each of the parentheses in my answer are difference of squares, so they each got broken down. Now make sure you look at each of the parentheses. Can anything be done here? No, that's not a square. Not a difference of squares, not a difference of squares, not a square. So yep, this is my final answer, which takes us back to the idea of prime. These problems are only done when each parenthesis is as low as it can go. Each parenthesis, each factor has to be prime, that nothing else can be taken out of it. So prime, again, is factors of 1 in itself. These are problems where you say, I can't do GCF. The other thing that I know how to do is group. Well, grouping doesn't work. I know how to do the product sum circles. And you look at those problems and say, nope, can't do product sum circles. And lastly, is it one of these special cases? Because sometimes the special cases can be done without the product sum circle. If you answer no to every single one of these, and you say no matter what I do, I can't find a way to factor it, then you're going to use prime, because the answer is it can't be factored because it has an answer of only 1 in itself. Prime is not reserved for when you're stuck. Prime literally means you've done everything. These problems should take a little bit longer and you can't find anything that works. Please let me know if you have any questions. Thank you.